10. A block of mass m is on a rough horizontal surface and is attached to a spring with spring constant k. The coefficient of kinetic friction between the surface and the block is mu. When the block is at position x equal to 0, the spring is at its unstretched length. The block is pulled to a position x equal to positive x0, as shown above, and released from rest. The block then travels to the left and passes through x equal to 0 before coming momentarily to rest at position x equal to negative x0 over 2. Which of the following is a correct expression for the coefficient of kinetic friction mu? The best approach to solve this is conservation of energy in the presence of non-conservative forces. We start out with an elastic potential energy at x0. We end up with elastic potential energy at negative x0 over 2, and we have negative work done by friction. On the left-hand side of the equation, we have 1/2 k x0 squared. On the right-hand side, we have 1/2 k x0 squared over 4 plus mu times mg times the total displacement, which is 3x0 over 2. The negative sign has changed to positive because of the cosine of 180 degrees between the force and displacement vectors. Doing a little algebra, we get 3/8 of k x0 squared is equal to 3/2 mu mg x0. This equation simplifies to 1/4 k x0 over mg is equal to mu. Therefore, our option is A.